Hi, in this video we're going to go back to looking at problems from the mathematics of investment and credit. And in fact, we're finally going to be done with chapter 2 now. We're going to go into chapter 3, which is about loans. However, what we learned about annuities is certainly going to apply to thinking about loans. This video is going to be kind of long because it's a multiple part problem, but I think it's definitely worth your while to get the basics about loans down. A lot of good information we'll get across in this video. Also, there are not as many S problems in Chapter 3, so I think I better do more problems, a fair amount more than just the S-labeled ones. This is problem 3.1.1. We're going to be given annual payments and an effective annual interest rate on a certain loan. We'll be finding some things. We'll be finding the loan amount, some outstanding balances, and the interest and principal on a given payment. So here is the problem. This is an amortized loan. I don't want to get into what an amortized loan is at the moment other than just to say, well, it is a loan and it's a method of payback in a sense. A sort of somewhat standard method of payback. A loan is where you are borrowing some money, say from a bank, to buy a car or buy a house, something like that. This loan has 10 annual payments that you need to pay back to the bank at the end of each year, starting 1 year from now. So the payments are going to form an annuity immediate. So Chapter 2 ideas still apply. The first 5 payments are $1,000 each, and the final 5 payments are $500 each. It's not a level annuity. Interest is at an effective annual rate of 10%. Find each of the following. Part 1, the initial loan amount. Part 2, the outstanding balance just after the 3rd payment. Part 3, the interest and payment in principal on the 4th payment. And 4th part is the outstanding balance just after the 8th payment. We still will want to think about timelines. Let me go ahead and label all the years here, 0, 1, 2, 3, etc. The payments form an annuity immediate, so we're starting 1 year after after we take out the loan. We've got a $1,000 payment here. The first 5 payments are all $1,000, and then the last 5 payments are all $500. To answer part 1, it's fairly simple. The idea is that the loan amount, the amount you are borrowing, is the same as the present value of all the payments based on the given interest rate. So the loan amount, which we might call L, is the present value of all these payments for the given interest rate of effective annual rate of 10% here. So we could write this symbolically as 1,000 times A 5.1, that'll be the present value of these 5 payments, plus 500 times A 5.1, giving us the present value of these payments at time 5, but we need to get back to time 0, so we need to multiply by V to the 5th as well, where V is going to be 1 over 1.1, 1 over 1 plus I, and that turns out to be 0.90 repeating. All right, so now it's just a matter of finding these things. You might want to factor out a 500 A 5.1 like this if you like. You don't have to, but that might make your work a little bit easier. Of course, A 5.1 is going to be 1 minus V to the 5th over 0.1. Let's store the value of V in register 0. It's the reciprocal of 1.1. I'll store that in register 0. We'll need it for a few different spots here. Let's raise it to the 5th power. Subtract that from 1. Divide by 0.1. The value of A 5.1 here is 3.79 approximately. 3.7907867. Is that worth storing? I'm not sure. Let's go ahead and store it. I'm going to store this in register 1, just in case we need it. I'll put a little 1 by that. And the value of V again is in register 0. Let's see, times 500. So that this part right there, I'll write down as 1895.393385. That might be worth storing as well. Store that in register 2. I probably won't need it later, but I'll store it anyway. Okay, now calculate V to the 5th. Recall 0. raised to the 5th power, add 2, multiply by this, which is in register 2. The final answer for the loan amount is $4,967.67, or 68 if you round it, dollars. 4976, or excuse me, 4967.676938 if we carry more decimals, just to play it safe for later on. All right, what about part 2? The outstanding balance just after the 3rd payment at time 3, essentially, just after we've made this 1,000 payment. Let's do this in a few different ways. There are formulas for this in a sense, but I'd like to start by doing it sort of step by step to show you how the loan amount goes, or the outstanding balance on your loan amount goes down over time. The outstanding balance at time 0 is the loan amount. And let me go ahead here and use more decimals. I'll stop, say right there. That's going to be the outstanding balance at time 0, the loan amount itself. The interest that you're going to owe during the first period, during the first year in this case, label it I1, is going to be the outstanding balance at time 0 times the interest rate, I, which is 10%. So just take 10% of that. That'll be 496.77 when you round it, but let me carry more decimals again. Okay, oftentimes in the examples in the book they do go ahead and round. That's how much interest you owe in the first payment. Now the first payment is 1,000, so whatever else above this you have goes to reducing the balance, goes toward principal reduction. We call that PR sub 1. That'll be 1,000 minus this, and that will be 503 point, let's see, it'll be 23231 if you do that subtraction there. That's how much the balance goes down by. So we get an outstanding balance at time 1 of the difference, this minus that. I've got the decimals here. Let me go ahead and subtract 503.23231. The outstanding balance at time 1 is going to be 4464.44. Let me go ahead and carry more decimals again. Might be too many, but oh well. So your balance went down by this much. The interest you're going to owe during the second year is going to be that balance times I, multiplied by 10% again. It'll be about 446.44. Once again, carrying more decimals just to play it safe here. I can write that. The principal reduction in that second year after that second payment is going to be the $1,000 payment minus this thing, and that will be 553.5555372. Do that subtraction. So your outstanding balance goes down by that much. So take this number and subtract 553.5555372. It's about 3910.89. We're almost to outstanding balance at time 3. Hang with me here. The interest that we pay during the third year is going to be 10% of that. The principal reduction after that third payment will be 1,000 minus this amount there, and that will be 608.9110 would be 91. So the answer for the outstanding balance at time 3 should now be this 3910 minus the 608, minus 608.911091. Let's go ahead and round this to the nearest cent now. 3301.98. That is the answer to part 2 here. But that was kind of a pain to have to go through that. Is there a better method? Yeah, there is a better method. There's a couple methods that you could consider to be better. We can also think of the outstanding balance more quickly in a couple different ways. we could think of it as the present value at time 3 of all the remaining payments. Let's see if we get the same answer when we do that. So present value at time 3 of all these remaining payments, we've got 2 payments of 1,000 that are paid over the next 2 years, at the end of the next 2 years. So its present value at time 3 is going to be 1,000 A2.1. And then we have these 5 payments of 500. If you discount those back to time 5 and then multiply by v squared to get to time 3, that'll be part of the balance as well. So we'll have 500 v squared A 5.1. We already know A5.1. In fact, it's in register 1. This was 3.79078677. I'm looking right there. That's what that was. We do need to figure out this thing. A2.1, that'll be take v and square it. Subtract that from 1, divide by I, which is 0.1. This value is 1.735533719. Multiply it by 1,000. You get 1735.537. Let's just round it that much. Let's see, coming back over to this part, we've got a v squared, call 0, again, square that, times 500, times this number, which was in register 1, gives us, you can see that there, 1566.4408. Add these now and round to the nearest cent, and we do indeed get the same answer. Okay, let me show you yet another way to find the answer, though I won't do it completely. I'll let you take the time to do it completely on your own. The method we just did is called the prospective method because it sort of looks forward in time. The next method I'm going to show you is called the retrospective method because it sort of looks backward in time. You take the original loan balance, 4967 point, let's carry more decimal places, 6769, OB0, and promote it in time to time 3 by multiplying by the growth factor cubed, the annual growth factor cubed, and then subtract the value at time 3 of the payments that have happened so far. Subtract 1,000 times the future value of 3 payments as an annuity immediate, S3.1. I guess this is quick enough that we can do it maybe with the calculator quick here. Let's just see that we get the same thing here. So let's figure out this one first. So S3.1, that's going to be 1.1 cubed minus 1 divided by 0.1 and then times 1,000. This is a cool 3310 exactly. Subtract that from this thing. Let's go ahead and calculate this. 1.1 cubed times 4967.6769. Subtract 3310. And once again, we get the exact same answer. Okay, so it's good to see that you get the same answer with these 3 methods. Okay, we've got 2 more parts to do still. I know I've taken a lot of time. I'm close to being out of paper here. Let's see if we can quickly do parts 3 and 4. I think we can do these pretty quickly. Part 3 here is to calculate the interest and principal on the 4th payment. The interest on the 4th payment is going to be the outstanding balance on the after the 3rd payment times the interest rate. So take the answer that we just got from part 2 and multiply it by 0.1. It'll be $330.20 if you round it. Okay, so that'll be the interest payment, and then the principal reduction, if you will, is just the $1,000 payment at time 4 minus the interest. If that payment was something different, like 500, we'd have to subtract the interest from 500. But this is going to be 1,000 minus 330.20, and that will be 669.80. That's how much your principal gets reduced with that fourth payment. Finally, the outstanding balance after the fourth, just after the eighth payment right there, after that payment of 500, is probably best to do with this with the prospective method. It's just going to be the present value, the remaining payments, 2 payments of 500. And lo and behold, we do have the value of A2.1. It was right there. So we can use that 1.79, or excuse me, 1.73553719, looking right there, times 500. The balance, outstanding balance just after the eighth payment is 867.77. Yeah, if you round it.